All right, part 2 of lesson 2.4. I have just 2 examples left, but these are the more challenging problems in the lesson, so that's why I decided to put them in a separate video. Okay, so for this example, we're going to start with isolating the radical. So anything that's not part of the radical, move it to the other side. So we will be subtracting t to make that happen. Okay, from here, your next task is to get rid of the square root. So we will square both sides of the equation to make that happen. And on the left side, the square root and the squared will just cancel each other out. So you'll just have t minus 2. But on the right side, remember that if you have more than one thing in the parentheses and you're squaring it, that means that you are supposed to be multiplying that thing by itself. So we need to actually FOIL to multiply all of this out. I'm going to go ahead and do that next and just drop down the t minus 2. So here I am FOILing or distributing, whatever you want to call it. So you would have 16 minus 4t minus 4t plus t squared. And then at this point, you're going to want to simplify. So you've got t minus 2 on the left, and then on the right side, you do have like terms that you can combine. Here we go. Oh, no. There we go. Okay, now I have the same situation as the last example on part 1 video where I have squared, t squared, and t. So my job to solve will be to put everything on one side and combine like terms, and then factor from there. So I have 18 minus 9t plus t squared. I'm going to actually rearrange this so that it looks more normal. We are used to having the squared term first and then the constant value last. So that looks a little bit more typical. And then we're factoring. So one more time with factoring, the way that this works is you're looking for what times what equals 18. That adds up to negative 9. So 6 times 3 equals 18. And if it's a negative 6 and a negative 3, then it will add up to a negative 9. From here, the last step is to set each factor equal to 0 and solve. So t minus 6 equals 0. We're going to add and get that t is equal to 6. That's one answer. And then the other answer looks like it's going to be positive 3. Okay, reminder that these answers may or may not actually work when we go back and check. So we have to do the checking step of plugging in 6 and plugging in 3 back into the original equation to see if they actually work. So if I plug 6 into this original equation, here's what it would look like. I'm going to start solving. So the radical would be square root of 4 plus 6 equals 4. And the square root of 4 is 2. 2 plus 6 does not equal 4. So that does not work. So 6 is not an actual solution. We would, again, call this extraneous. And now we're going to try 3. So plug 3 in everywhere that you see t. Keep in mind that just because one of your answers is extraneous doesn't mean that the other one will not be. Sometimes they're both extraneous, sometimes neither one's extraneous, so you do have to do this check each time. So square root of 1 plus 3, the square root of 1 is 1. 1 plus 3 is 4. So that one's fine. We have a single answer then of t equals 3. We're going to do one more example. And this last one is going to be what one of the most challenging problems that you will see will look like. Okay, so I'm going to start with, I have a radical. I kind of want to isolate the radical. I'm not going to isolate completely, but I am going to move the 3x over to the other side. So I'm going to make this -5 radical x equals 2 minus, actually, let me write it a different way. Let me write it like -3x plus 2. And then I'm going to divide, I'm not going to divide by 5 because that's going to create fractions over here. I'm just going to divide by the negative. So it's going to make this 5 radical x equals positive 3x and -2. Okay, now I'm going to square both sides. And so when I square both sides, the radical will go away. But I also will have a lot of work to do over here on the right side, similar to the last example where we have to multiply 3x minus 2 by itself. So we're going to have to FOIL that out. But on the left, 5 radical x squared. Well, 5 squared would be 25, and radical x squared would just be x. So that would be 25x over there. And then on the right, like I said, we're going to do FOIL. So this would be 9x squared minus 6x minus 6x plus 4. Okay, we have like terms. So we're going to simplify and add the like terms together and get -12x. And then this is that same situation where we have an x squared and an x. So the only way we can solve equations like this is to put everything on one side and factor. So that's what we're doing now. I'm putting the 25x over on the right side, and I'm combining like terms as I go, and I have to factor this. Okay, it's been a lot of work to do this problem so far, but there's an extra step here. It's a little different. Yeah, we're factoring, but this factoring is a little bit different than the others because we have a 9x squared. It's just instead of just an x squared. So I have to say 9x times x is 9x squared, or 3x times 3x could work. We don't know really what the right choice is until we check. So for now, we're just going to try this out. And then I need something times something that equals 4. So I'm going to try 2 times 2. And I'm going to try a -2 times a -2 to get a positive 4, because I see a negative here in the middle that I need to try to figure out. Okay, to check your work, technically you need to FOIL all of this out to make sure that it equals 9x squared minus 37x plus 4. But I already know that 9x times x is 9x squared. And I already know -2 times -2 is 4. So really this is the question at hand, is do the middle terms add up to -37? So we're just going to check that part. And we're going to do so by multiplying the outside 2 terms together, the inside 2 terms together, and then combining them. So 9x times -2 would be -18x. -2 times x would be -2x. And if we combine like terms, we get -20x. That does not match what's in the middle here. Therefore, the 2 and the 2 was not the right combination. So we need to think of something else that could possibly work. So we're going back to the drawing board and saying, what times what equals 4? Well, 1 times 4 is 4. So let's try that combo and see if that works better. 9x times -4 would be -36x. -1 times x is -1x. And if you combine like terms, you get -37x. And that is what we wanted. So we have the correct factorization now, which means we can proceed to the step where we set each term equal to 0 and solve. For the first equation, our last step is to divide by 9, but we can't divide 1 by 9, so we're just going to leave it as 1/9 rather than a decimal. And the second equation is going to solve to x equals 4. Okay, you know the drill at this point. The last step is to check your work. So we're going to check and see if 1/9 is actually a legit answer. So that means plugging in 1/9 everywhere you see an x. And you can use a calculator for this. So if this is too confusing, don't worry, just grab a calculator. I'm going to go ahead without. So 3 times 1/9 would be 3/9, which reduces to 1/3. The square root of 1/9, all I have to do is square root the top and square root the bottom. So that would be 1/3. And I still don't know if this equals 2. So let's keep going. 1/3 minus 5 times 1/3 would be 5/3. And 1/3 minus 5/3 is negative 4/3, which that is not equal to 2. So 1/9 is an extraneous solution, meaning it does not work. So I got to check and see if 4 is going to be okay or not. So we're going to plug in 4 everywhere that we see an x. This gives me 12 minus 5 times the square root of 4 is 2. And that would give us 10. 12 minus 10 does equal 2. So 4 is good to go. Now, quick warning. Your homework is on Delta Math. You do have to show your work per the directions posted on Classroom. I just wanted to warn you, though, that when you're entering your answers on Delta Math, if you have an extraneous solution, do not type it in as an answer. Extraneous means that you solved and got it as an answer, but it doesn't actually work in the equation, so therefore it's not a solution. So for this particular example, 4 is all you would type in on Delta Math. You would not type in 1/9 as an answer. It is possible that both of your answers are extraneous. If that's the case, just leave the answer box blank on Delta Math and submit it like that, because then the computer will read it as you mean there's no answers or no solution.